Hello everyone. We are the Power Generating Wind Mitigation Device team. I am Marcos, Joel, and Junior with me. Problem statement: there is a need for innovative engineering solutions to mitigate the damage and destruction caused by hurricanes. Also, the post-hurricane power outages are a major concern. And there is a need for clean energy generation using renewable resources, and we try to address this problem with this project. I want to direct your attention to this couple of pictures here. As you can see, house damage usually starts by roof failure. And why is that? Shown in the top right picture, you can see those arrows represent the wind striking the house at a 90-degree angle. You can see at the edge of the roof how these vortices are formed. Now these vortices generate a very high pressure difference which causes that roof uplift. At the top, the bottom right picture, you can also see the wind striking the house at an angle and how two conical vortices are formed, generating this pressure difference. Now, what can we do to approach this problem? There have been some passive mitigation devices already in place, like, for example, those pictures that you can see up there. However, what we're trying to do with this project is a completely new approach of a dynamic device that will harvest the energy of the wind as well as alter the direction of the flow. Now, there have been some considerations. We've taken significant reduction of wind uplift. Of course, this is the main focus of this project, but we've thought about safe operation, quiet operation, low cost, etc. And now Joel will explain to you a little bit about our first proposed design.
Thank you, Marcos. So this is our proposed design, the CAD model, and the prototype that we already built. You can see it over there. Now let's see some of the dimensions of this prototype. We have 3 blades, evenly separated at 120 degrees, an angle of twist of 90 degrees, and a length of 36 inches. We choose this model because it's simple, feasible, and since this is a new approach to wind mitigation, we wanted to ratify our concept before continue the entire design. So, how much time do we have to complete this project? What you see here is our timeline. The dark green represents what we have already done. The light green is what we have ahead of us. Let's see a little bit about the impact we are expecting from this device. First of all, environmental, because it will be generating electricity from an inaccessible energy source. Second, global, because it's targeted to all tropical countries that are annually affected by hurricanes. And last but not least, economic, because it will reduce the cost of electricity and reduce the damage generated by the hurricanes. Now, nonetheless, the biggest impact will be creating a device with the potential to save a life. Now let's see some of the initial results obtained. We started with the CFD analysis, and what you see here is the pressure profile of the flat roof of a cubic house that appears on the top right corner. Both images use the same pressure scale, where the blue represents the negative pressure. The comparison shows a 30% reduction while in the presence of the device, of the pressure difference in the entire roof. Now Junior is going to explain some of the experimental results.
Thank you, Joel. What you can see here is the effect of the cornering wind as it approaches a 45-degree angle to a curious structure. And this is the scoring effect on this side is more pronounced due to the conical vortices. The wind speed was 10 meters per second. You can see the device is mitigating also the wind loading on the other side, reducing the pressure suction on the roof. This picture was taken after the experiment was performed. This shows a 70% reduction with the device and without the device. Since this is a preliminary prototype, further testing and validation are required. In order to accomplish this goal, we have to take into consideration different design variables such as length of the turbine, number of blade shapes, and also different roof geometries. In order for further testing, we will be using the FIU wall of wind, and we also want to continue to use CFD analysis to correlate both results. We want to say thank you to our advisor, Dr. Andres Tremante, thank you to our PhD candidate, Javier Palencia, and to the RISE team, Paola and Sergio, and also to the FIU Wall of Wind research staff. This concludes our presentation. Thank you very much.
Do we have any questions now? Yes, please.
Why do I want this? What does this do for me? Would I put this on my house?
It would protect your house.
So the goal here is that I would buy this and put it on the corners of my house is to mitigate, so it doesn't fly off during a hurricane?
No. first.
Go ahead.
Yeah, let me go ahead. Right now, most of the houses in Miami and other areas that are affected by hurricanes use some passive mitigation devices. In flat roof, you can see in many ways. So our concept is trying to create a dynamic mitigation device that is not only going to protect your house in the case of a hurricane, it's always going to produce electricity from the air. Basically, this is what it's a wind turbine that's going to be generating electricity all year long, and in the case of a hurricane, it's going to mitigate the effects of the uplift effect.
Have you, at some point in your project, are you going to determine the magnitude of mitigation to say that if I put this on and I have a hurricane 2, I'll keep my roof, but at 4, I'm gone?
At this point, we have different constraints, such as horizontal wind turbine, and also we are going to be dealing with between 2 meters per second and 42.5 meters per second, which is a hurricane, category 1 hurricane. So we have to further consider that, but it's just a preliminary prototype to prove that our concept is going to work, but we still.
Eventually, that would be your goal?
Yes.
Are you going to do any work to tell me how large or how many of these I will need per square footage of my roof, be able to protect my roof in a hurricane?
So, yeah.
Absolutely. We have to consider that, of course, because there are many different kinds of houses, many different kinds of roofs. That would definitely have to consider that. At this moment, we just had this preliminary prototype based on a 3x3 small house. So we definitely have to consider that, further consider. Absolutely.
So if you scale that up to a 4,400 square, let's say a 4,000 square foot home, how many of these am I going to need and get my house?
This is just a prototype to scale 3:1 of the initial design that we create to see if the concept of active mitigation can be applied. Now, the turbine should be placed close at the same height in the edge of the houses, all along the edge of the houses. What we proved there with the angle 45 degree angle is we're gonna need to protect the entire roof. We're gonna need a turbine that needs, or at least one turbine in each corner of the house. It's all around the house in order to protect and mitigate that effect.
Do you have a plan to use a wall of wind to test? I just got back in the room. I don't know if you covered that.
Yes, we mentioned for further testing, the FIU wall of wind will open the doors so we can work on the prototyping.
We'll be working with the research staff over there, then giving us some input on here.
So you'll be able to validate all of your theoretical predictions and all of that.
That's what we want. Absolutely.
Yes.
Exactly. That's the goal. If we can get there, that depends on if we can get financing, or because that's
Are you working that out now?
Yes,
absolutely.
Actually, we have to build this prototype because we participate together with the Flash team in a Flash conference in Orlando. In order to get some financing, we got second place. So.
And Wall of Wind won't give you a break because you're here at FIU?
Wow.
We're still talking about it.
Yeah.
We're still trying to convince them.
We're working. We hope so.
We're working on that.
Yeah, we're working together.
Okay.
Yeah,
All right.
This is basically we're part of other teams. Our project is to work on the turbine part. So we're working towards the same goal, which is renewable energy.
Yeah.
This is opportunities.
Tell Wall of Wind you'll give them credit.
Yes.
Yeah.
All right.
But talk a little bit more about the cost for someone who wants to because this is what, you're going to do this for residents? This is residential?
Yeah.
Yes.
Our initial approach is residential.
Right, so someone who eventually is going to go and buy one of these things.
Well, just to give you an idea, this prototype, we spent almost $150 just to get the wood, and also we put like a week of work So it's roughly like $500, we can say that, $600 between labor and the parts. However, for the actual prototype, the scale, we're looking into, once we determine what generator is gonna be used and all of that, we're looking maybe at $10,000, just to give you an idea.
So the average person, it would be practical for them to go to buy that, or just maybe let the house just blow?
Well,
And insurance takes care of
yeah,
it.
if you see,
Exactly.
we have, actually, the government has plans to reduce the cost of these type of devices. We actually, the state of Florida has an inspection that if your house is protected, then you pay less in insurance. So you're saving money there. Then you actually are generating electricity at the end. The device is supposed to generate electricity, so you're saving some money there too, because you're generating electricity from the air, and your house is gonna be safer. So you have multiple reasons why to buy it. At this point, we just have the design, so we cannot predict the final impact of the project, and we understand that, but that's the impact we see it right now.
Just to add to that, at this point, there's a couple of tax breaks. There's a tax break for implementing mitigation devices, and there's also a tax break for implementing the use of renewable resources. I think one is 30% and the other one is 25? Okay, 25%. So that also will contribute to lower, definitely lower the cost, the final cost of the device. But just keep in mind that this is the very first stage. This is a completely new approach. It's never been done before. So we still have a lot to do. We still have a lot to do and to study. But thank you so much. It's definitely something we have to consider.
Do you have any other questions?
Thank you very much.